What's up, everybody? Mr. Stahl, we're back for another day of the math geometry lessons. And today we're going to start off by doing a little distance formula work, right? So I already wrote out the distance formula on our warm-up screen. It says d equals the square root x2 minus x1 squared plus y2 minus y1 squared, right? And the way that we always start off these problems is label the points that you're given, right? So we have x1, y1 in our first coordinate, x2, y2 in our second coordinate. And all we have to do is plug these things in. So we get d equals the square root big, and we get x2 is going to be 16 minus 9 squared plus 2 minus 4 squared. And first thing we have to do to start solving this is by solving things inside the parentheses. We get d equals the square root 16 minus 9 is going to give me 7 squared plus 2 minus 4 is going to give me a negative 2 for that. Now we do our exponents. So we're going to square 7 and square negative 2. We get d equals square root of 7 squared. 7 squared is really just 7 times 7. That's going to be 49 plus negative 2 times negative 2, because that's what negative 2 squared is. And that's going to be 4. Now all we have to do is say d equals square root, add these two together. It's going to give me 53. I'm going to leave it just like that. Awesome. So if you're trying to feel confident in your math, take a second, pause this video, try the next one before we go over it. All right. If you paused, follow along. If not, follow along anyway. For our next one, let me change colors just to break things up. Once again, start off by labeling your points. x1, y1, x2, y2. And now you plug them in. D equals the square root x2, 2 minus 0 squared plus 4 minus, but then it's a negative 5, so we're going to change that minus to a plus 5. So then we write d equals the square root 2 minus 0 is 2 squared plus 4 plus 5, 9 squared. That up. Now we got to square both. D equals root 2 squared is 2 times 2, so that's going to give me 4 plus 9 squared is just 9 times 9. That's going to give me 81. Add those together and we get d equals square root of 85. There's our second answer. There we go. Nice and simple. So let's get into our lesson for today. We're going to be using our distance formula a little bit here and there to have ideas for things. So our lesson for today is called Jack's spare key. And we're talking about partitioning segments in given ratios. So how to cut line segments up, mostly on our coordinate plane. That's what we're going to be talking about today. We're going to use the distance formula to partition a direct line segment into given ratio, determining the coordinates of the point which divides the line and segment ratio. We use geometric reasoning and proportionality to partition a direct line segment into a given ratio, blah, 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 right? Basically, what we're saying is we're going to be using different tools to split up our line segments, to cut them into sections. So, partitioning direct line segments. One thing to think about is the midpoint of the line segment divides the line into a 1-to-1 ratio, right? Because it's a midpoint, so it's cutting it into 2 equal sections, which are 1-to-1. Each half of the line segment is the same length. Let's explore distances with different ratios. That's what we're gonna look at. So let's start out with our first problem. It says Jack buried a spare key to his house in the backyard in case of emergency. Location of the back door is at point B, 2, 3, which we already see on our coordinate plane. And the location of the oak tree is point T, 12, 3, which also is on our coordinate plane. Part A says, suppose Jack buried his spare key 1/3 of the way between the back door and the oak tree. Determine the location of the key. Plot and label the location as point K. So what we're going to want to do is find the distance between these 2 points, right? So what we could do, since we're lucky, since they're on the same horizontal line, we could just count for this one. We don't have to use our distance formula. But we want to find the distance first. And what we could say is it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10 units apart, right? So the distance between those two things are 10. And what we want to do now is divide that. We get 10 thirds, right? And that means that our point is 10 thirds after this, right? So what we then need to do in order to figure out where our point is, we need to realize we're not starting from 0. So we can't just say, oh, it's at 10 thirds, x 10 thirds, right? What we want to do is add this to our x, right? And our x here is 2. But we need to write 2 as a fraction, so we're going to say plus 6/3. Because if we do that, 6 divided by 3 gives me 2. That makes sense. Now we could add these fractions. It's going to give me 16/3. So our coordinate, point K, we could say K is going to be 16/3, comma, and then if we notice, everything on this line here has the y coordinate of 3. As we could look, it says B up here is 2, 3, C is 2, 3, or 12, 3. So it's going to be 16/3/3. And just to get an idea of where 16/3 is for our brain, what we could do is we could divide that in a calculator. If I open up a calculator, we could say 16 divided by 3 is about 5.333 repeating. So that's where we need to go on our coordinate plane. We're here at 2, 3, 4, 5. We're going to go a little more than 5. We're going to put our point there. That's going to be point A. And that's where he buried his key. So it says point K divides the distance between distance BT into different ratios, depending on where you start. At B and move to T, or start at T and move to B. So it says, in what ratio does point K divide the distance BT? Starting at the back door and moving to the tree. So what is the ratio here? And our ratio, the way we could think about it is, since we cut this into a third, that means there's technically 3 parts here, right? And what we could technically do, let's say I have a different color and we had another thing here, right? So we moved 1, 2, 3, and a little more. Go 1, 2, 3, a little more. This point right here, cut it into our other third. So now you can see those 3 sections from B to K, K to our blue dot, and our blue dot to T. We have thirds. So what we could say is, if we want to write a ratio for K from B to T, we say how many thirds is before K, right? We get 1/3. So our ratio is going to be 1 to 2. We could write 1 to 2 ratio. That is our ratio for this problem. A 1 to 2 ratio. And you might say, hey, but I thought we cut it into thirds, right? Well, we did. And if you add 1 and 2, what does it give you? It gives you 3. That means there's 3 parts total, right? 1 part before the point, and then 2 parts after the point. And our point here is K. Now, it says, In what ratio does k divide the distance t to b? Now, if we were going from t the opposite way, how many parts are before k? We have 1 part, 2 parts. So it's going to be a 2 to 1 ratio. Notice how it flips because we're going in the opposite direction. So our ratio will flip on us just like that. There we go. We dabbled a little bit with ratios. Now, I understand this could be a little confusing to some people. Some people might just understand it right away. The thing with that is if you're confused, ask for help, right? Teacher might be able to explain it into a different way or just help you get through any questions that you may have about it. If you don't have a teacher to ask, be sure to leave a comment down below and I could help get back to you on that. So let's keep it cruising, right? So we see something here and it says, when thinking about a line segment and direction, it's important. You can think about the line segment as a directed line segment. So it's a line segment with direction. Path between the back door and the tree can represent a directed line segment, BT. Mathematically, this is different from the directed line segment, TB. So naming it is important because naming it is telling me the direction I want to go, right? There is a difference between BT and TB because one, we're going from the back door to the tree. The other one, we're going from the tree to the back door, right? So it says the path from the tree to the back door. Oh, sorry. I finished the sentence after going on a tangent. Whoops. TB is the path from the tree to the back door. So that's the important thing right here is our directed line segment. The line segment where direction is important, right? We can't just name it both names and say, hey, they're the same thing. They mean different things because we're traveling either one direction or the other. Awesome. So now it says Jean also buried a house key. She remembers burying the key between the front porch and the rose bush. The location of the front porch is point P 1, 2. And the location of the rose bush is at point R 16, 14. So the thing we have to do here is go and we have to say, hey, these points aren't on my grid anymore. So we have to find them. We're going to start our origin 0, 0. And first off, we're going to go to 1, 2. The 1 is our X, so we're going to go right 1 and up 2. And there we go. We have our point D. That represents our porch. Then we have to do R, which is 16, 14. Once again, start at 0. We're going to slide right all the way down to 16. And then we're going to go all the way up to 14. Yeah. Awesome. And that is going to be R, which is our rose bush. And now we can get to our question. Now that we wrote down our pivotal information from the top text, the situation, the setup, we could get to our question and help answer that. This is determine the location of Jean's key in each situation. In what ratio does the location of the key divide the directed line segment PR? In what ratio does it divide the directed line segment RP? So we want to figure out where the key is and then say, hey, what ratio does it direct this line segment? So it says, suppose Jean buried her key 1/2 of the way between the front porch and the rose bush. So the problem with this situation here is we don't know where 1/2 is here, right? So we're going to have to find what we call our midpoint. In order to do that is we could add the coordinates and divide by 2. So how do we do this? Right, big parentheses, and we could say our x coordinates, 1 plus 16. So 1 plus 16, we're going to divide that by 2, comma, or 2 plus 14. 2 plus 14, and we're going to divide that by 2, right? And what will this give me? This is going to give me 17 over 2, comma, and this is going to give me 16 up top, divided by 2 is 8. Right? So this is where we have to go. We have to go to 17 over 2, which is really like, actually, if we write this as a decimal, it'll probably be easier for our brains to understand. That's really like 8.5, right? We're going to go to 8.5 on our x, right? And then we're going to go up to 8, and that's going to be halfway, right? So this is where our key is. So I'm going to put a k next to that. That's where our key is. Now, what is the ratio here? Well, this is halfway, so we have two segments, right? We have p to k and then k to r, right? There's no other segments here. We're only dividing this line into two, right? So that means our ratio either way is going to be 1 to 1. That's going to be our ratio. Whenever you're dividing something in half, you're going to have that 1-to-1 ratio because those two segments on either side are equal. 1 and 1 are equal, so it all comes out to make sense. Let's move to our next problem. So our next problem, we have the same situation, except now it changed place where she buries her key. It's 1/4 of the way between the front porch and the rose bush. So what we can do now is, once again, let's start off by plotting our original points. 1, 2, going to be P, and then 16 to 14, which is going to be R. And now we have to think about how can we plot this point so that it's a quarter of the way through. So the way we could do this one is a little different, right? So what do we have to do here? So how can we solve this problem? The way we're going to go about this one is by thinking about what's the difference between our two coordinates here and then dividing it by what our division here. So the 1/4, right? For our first one, let's look at our x coordinate. So I'm going to put x coord. Right? And for our x coordinate, we could say it's going to be 16 minus 1. 16 minus 1. I always do my second point minus my first point. That's going to give me 15, right? And what we want to do now is do that divided by 4. And what's that going to give me? That's going to give me about 3.75, right? And that number is important because what we're going to want to do from that number is we're going to want to add that to our point P. And that's going to tell us what 1/4 of the way is, right? So that is 1/4. And then we want to do that for our y coordinates. So y coordinate. And in order to do this one, we do 14 minus 2. So our second y coordinate for R minus our y coordinate for P. And that's going to give me 12. And now we need to divide that by 4, which will give me 3. So now what we want to do is we want to start at point P. In order to find our first point here, which is where Jean buries the key, we're going to say our first point, 1, 2, and we're going to add, so plus 3.75 to my x and comma 3, which will give me k, where the key is, and that's going to be 4.75 comma 4. Or sorry, 5. 3 plus 2 is 5. And that is where the key will be buried. We partition this line. So let's go to that point. Go to 4. 4.75 is around here. We got to go up 5. Be about there. And this is going to be point K. Now, if we want to break our line up into all 4 of these chunks, since we're dividing it by 4s, we could keep adding. I could say plus 3.75, comma 3, right? And our next point would be at, I don't know, my brain's still waking up. 4.75 plus 3 0.75. 0.5 plus 8.5. 8.5, comma, 5 plus 3 is 8. And that's halfway, which we found out in the last problem. So that makes sense, right? Because if we do it twice, that'd be 2/4, right? Which would be halfway through our line. We go to 8.5, up to 8, and that cuts it halfway. And then we add one more, do 3.75, comma 3. We add that on, and that's going to give me 8.5 plus 3.5 would be 12.25, comma 8 plus 3 is 11. I'm going to go 12.25 all the way up to 11. Be about here, and there we go. We divided it. Now you don't have to do this. The reason I'm doing this is for the part that follows. Is it asks us what is the ratios PR, the directed line segment PR, and then our directed line segment RP. So if we put PR here, and we want to find ratio, right? What is the ratio for PR? If I start at P and then go to R, how many chunks are before P? Before K? We get 1. We're gonna have a 1, 2, and how many are after? 1, 2, 3. So 3. A 1-to-3 ratio for PR. But if we want RP, we could write it as follows. We do the opposite way. How many chunks from R to K? 1, 2, 3, 2, 1. And there we go. We wrote out our ratios. And we cut up our line segment. Let's see our next one. Now it says, Gene buried the key 1/3 of the way between the front porch and the rose bush. So once again, what can we do? We have to do the same strategy as we did in our last problem. First off, let's start by plotting our points. 1, 2, which is at our front porch. And then 16, 14, which is our rose bush, R. Right? And what we're going to do is the same thing we did last time. We're going to subtract for our x coordinate. We're going to find the difference between the points. 16 minus 1, which gives me 15. And then we're going to divide that by 3, which will give me 5. So we're going to have to cut it off by 5 for my x. Or we're going to add 5 on my x. Y coordinate is going to be 14 minus 2, which will give me 12, divided by 3, which will be 4. Wow, that worked out easy for us, both numbers. So what we can then do is we start at P, right? Because we want to go, it says, suppose Jean buried her key 1/3 of the way between the front porch to the rose bush. So we start at our front porch, P, which is 1, 2, right? And we add plus 5 for my x, comma, 4. So adding 4 to my y. So our key is going to be at 1 plus 5 is 6. 2 plus 4 is 6. So it's going to be at 6, 6. So we go 6, 6. There is our first. That's our, right? And if we did want to divide this, right, into all our chunks, we could put this a key, K there for key. We could just do it one more time, right? And this is because it's in thirds, it's quicker, right? So our next point will be at 6 plus 5 is 11, comma, 10. And there we go. Now we can see that this line that would be here is being cut up into 3 chunks, right? So once again, let's write our ratios. P, that's R, 1. P, R, be our first one. And that's going to be a 1 to 2 ratio. 1, 2. And then if we go the other way, RP, it's going to be a 2 to 1 ratio. And there we go. We are dividing line segments. Once again, if you have questions, let your teacher know. Have a teacher, as always, comment down below and I will help you out. I'll do my best to get back to you and answer your question. Keep an eye out. But if you do have questions, feel free to ask. And thank you for watching the video. See you next time.